Nice to see so many people here. We're going to talk about how Kotlin runs taxes in Norway. We're going to start with who we are, just a brief introduction. We're also going to show sort of the background of our talk, the Norwegian Tax Administration, the Aurora platform, that's the NTIA's cloud platform, and how that relates to Kotlin. We're also going to describe why we chose to use Kotlin and how we use Kotlin in different settings. And in that case, we're going to show an example at Storyteller. That's a service we run in NTIA. Storyteller uses coroutines of Flux, so we're going to show a few code examples from that. Also a bit of our experience using it, sort of the pain points and sort of what are the advantages of using it. We're going to give a brief introduction to Kotlin Gradle. It's going to be really brief, so if you have any questions, please talk to us afterwards. We have a lot of different topics, so it's going to be short and sweet on most of it, so please let us know if you want to know more. And at the end, we're going to show 2 use cases of DSLs where we use Kotlin to create domain-specific languages in NTIA, and sort of how we did it and sort of the benefits we had from it. So, who are we? Well, both Anders and me, we work for Systek. It's a mid-sized consultancy based in Oslo. We're about 60 people. I think we're 63 or something.
Something like that.
We're currently consultants at the Norwegian Tax Administration. I've been there for a while, about 2 years now. And we're also organizers of the Oslo Kotlin Meetup group. About myself, I have a PhD from Brunel University in London. At the moment, I'm doing real work. I'm working for the Norwegian Tax Administration. My email, my GitHub, if there are any questions, please let me know.
Yeah, so Anders Mikkelsen, previous tanker and veteran from the Norwegian Army, now rehabilitated developer, working for Systek and the NTIA. So, just a quick introduction to what's covered in this talk. We're going to talk about what experience NTIA has had with using Kotlin, a brief intro to different use cases, and there are going to be many different Kotlin-related subjects. And please contact us after the talk for more details if you want to discuss, because we can't dive into everything. So first, a bit about the NTIA.
So the Norwegian Tax Administration, it's quite big. It is about 6,500 employees in total, around 500 developers. It does tax calculation and enforcement, and it's also it has responsibility for the new national registry, so which registers all residents of Norway, current and former. So it's quite big, and the user base. There are 5.3 Norwegians in total, and of that, there's 4.9 million that has some sort of connection with the NTIA. It integrates with most other public services, and also integration with any company interfacing with the national registry. So most Norwegians has some sort of connection with the NTIA. A few years ago, they started a modernizing project where the Aurora platform was created. Aurora platform is the cloud initiative in NTIA. Most of it is open source. We'll look more into that later. We also have our documentation on GitHub.io. So if you're interested, that's the URL. Aurora is a PaaS, so a platform as a service. It's based on OpenShift. We have created a custom configuration and tooling. So a lot of the tooling is actually written in Kotlin, which we'll look more into. And we're using Kotlin for the most part, and also Kotlin Gradle. So there is a funny story to the names we use for our services. The first service was called Sprocket. The idea behind it was that it is a cogwheel, basically. That was what the developer thought. And another teammate said that Sprocket is actually the dog from Fraggle Rock. So that's how we started using Fraggle Rock characters. So our services are named after characters in Fraggle Rock. So to give a few examples, we have Berber, we have Gobo, we have Mean Genie, we have Moki. So it doesn't tell you much, but for instance, Gobo is our GraphQL gateway, and Berber is what talks to our OpenShift instance and stuff like that. There is a bunch of documentation on GitHub, as I've shown before. We also have some sort of justification. Why did we create the Aurora platform? What is the Aurora platform? And stuff like that. So if you want to read more, please go to the GitHub IO pages. We also have a bunch of documentation on our custom config. We're not going to go into details on this here, but this one shows the file hierarchy, and this one shows sort of the properties you can set in the files. We have a really open source mentality here, so we try to open source most of the Aurora platform. Most of the tools are available on GitHub with Apache 2 licenses. So if you want to use it, feel free. So we try to use other open source and we try to give back. That's the mentality. So why Kotlin? One really important thing in the beginning was that it's 100% compatible with Java. The NTIA was a Java shop. Most of the services was Java from before, and this made the transition really easy. We could, for instance, keep the tests, and we could rewrite the implementation using the same tests and make sure that it still works. Also important that libraries such as Spring and stuff like that that you're used to using in Java still works. The main part is sort of developer satisfaction. That's what's been driving the adoption of Kotlin. These points are nothing new. You've probably read them 1,000 times. But it's worth mentioning as these really provide the basis of why I think most developers are so happy. It's simple things, but it's really nice when you come from a Java background to have all of these nice tools available. So data classes, collection API, extension functions, null safety, when, reify types, and coroutines. We're not going to go deeper into this in this talk, but most of you probably know it already. NTIA satisfaction. So it was really important that the tests, that we could reuse the tests. We had a lot of tests from before. This made it easy to sort of take the first step in converting Java code into Kotlin. Also, it has broad scripting support, so both build script and Kotlin script, which is really nice. And domain-specific languages was quite a big advantage for us because a lot of the NTIA, where we need to build data, for instance, favor the DSL type solution. And this is well supported in Kotlin. We'll look more into this later. So what did we learn from adopting Kotlin? Well, first, it really creates great developer satisfaction. I think most of the developers are really, really happy with that transition. Features such as extension functions and null safety helps us avoid bugs, mistakes by modifying poor APIs. So it's a really nice tool to take an existing API that's maybe a bit clumsy and making it better, for instance, with extension functions. Certain libraries do not integrate with coroutines in not so obvious ways. We'll show you examples of this later. This is a bit, yeah, it can be difficult to notice when you're writing the code. For instance, thread local, we had a nasty bug with Spring Security where our token, it messed up the token we had in Spring Security. I think this is fixed now, but these things are, you keep it in the back of your head, basically. Kotlin Gradle has unpredictable syntax and can be slow. We'll also show you a brief example of this later.
All right, so I'm going to talk about Storyteller, which is one of the Fraggles on Aurora. And Storyteller is an internal service that we use for providing automated creation and destruction of environments across various infrastructures. We have what we call Classic, and we have OpenShift, and we have other ways of hosting. So we needed a unified solution for pulling things up and down, abstracted. So just some facts to put the scope on the infrastructure. We use OpenShift and primarily VMware. Around 6,500 VMs, maybe 300-400 for OpenShift. Around 950 pods in production, 5,500 overall. And this increases by about 50% each year, which is a result of this modernization effort that Jarle was talking about. So right now we have around 500 microservices in production for main services. So deployed so far this year by this September is around 140K. And that includes configuration changes, so not necessarily a new version. But that puts some scope on what infrastructure we're dealing with. So one of these environments is a collection of so-called segments, which is an organizational unit in the NTIA. So it can be a selection of many microservices, for example. So any standard general purpose testing environment might consist of hundreds of cores, thousands of gigabyte RAM, and just X amounts of storage. And on top of that, you have various constellations of legacy modernized apps and other things in both traditional setups and or as pods on OpenShift. So this takes a lot of time when you have a large environment. So we needed a way to do this quickly and parallelized. So we ended up with microservices and event-driven architecture that looks something like this. You have a primary API, which is Storyteller. We have an environment broker, which we call Big Mouth, which of course is another Fraggle. And then we have configuration, execution, and verification, which is provisioning infrastructure, deploying architecture, verifying architecture. And those are the Bulldozer, Choo Choo, and Convincing John Fraggles. So our tech stack is, of course, Kotlin, Spring Boot, which will cover most of the rest of our talk, and specifically purely web Flux based, and using coroutines and suspended functions for a completely reactive experience. And then we use Vertex for asynchronous coordination and retriability, as well as real-time updates for all our clients. So you can order an environment, and then you can get the continuous stream showing you the progress underway. And then we use Kafka for message distribution. So that's the frame with Storyteller, and then we can start looking at our experiences with Kotlin and Spring Boot. So the general experience, most functionality is just as expected right out of the box. Specifically with Spring 5.2 and Spring Boot 2.2, they solved a lot of issues with coroutines that we had before, but not all of them, which I'll come back to. So a lot of these things with Kotlin and coroutines are very well covered in other talks. So we are going to look at some of our particular things. So first we're going to look at some general annoyance. As a developer, you might find this annoying. For example, this. If you use a value annotation in Spring Boot for Kotlin, if it's a Spring expression language of a property, you need to escape the $sign, because that's a template string. You can, of course, use a hashtag if you want, but that's a different story. If you want to inject something in Java, you would do it like this at the top, which, of course, is nullable. Everything is nullable there. But if you want a non-null val in Kotlin, then you have to do this optional anyway, because the compiler doesn't understand that this will come later, right? So then you can use a late init var to inject this string. And then, of course, it's a var, which is in reality a val, but that's a different story. And then if you want to inject primitives, you can't inject the int, So then you must, for example, use the Java class integer. So that's a couple of annoyances around that. That's specifically with configuration properties. So injecting in constructor for Java is pretty straightforward. If you don't want to auto-wire in the class, you can auto-wire into the constructor. Auto-wiring in Kotlin has the same problem as before. You can get the val, but then you will have nullability issues. So usually you get the late init var, or else use primarily the constructor, where you get the one-up on Java, because there you can also define the property directly in the constructor, whereas you would have to reference a field in your Java class. If you just need it as an argument, you can do that as well. Suspended functions with Spring Fox. For now, just forget about it. Another complicated annoyance, which is for Spring Security specifically. And this is a general issue with a lot of Spring Boot packages that are not WebFlux specific. For example, for Spring Security and WebMVC, you would use the pre-authorize annotation to authorize based on granted authorities. And then you would, of course, use the enable global method security annotation. That is not usable with suspended functions, which again is a general issue with WebMVC. You can, of course, say that your method should be equals run blocking, but then, of course, it defeats the point because then it is blocking. So you can use this enable reactive method security annotation, which comes with WebFlux, which works with suspended functions. But that, of course, demands a mono or flux response with WebFlux, which WebFlux does not support for suspended function. So these kinds of things, they pop up, and it can be difficult to identify that this is going to be a problem when you start implementing it. So that's just an example of complicated annoyance. So for now, forget about pre-authorize. If you want to use it with suspended flows, you'll have to roll your own solution for that. So yeah. So that's a couple of annoyances, and now to the good stuff, which is coroutines and WebFlux. So first of all, what is WebFlux? For those of you who don't know, it's a reactive programming model for Spring Boot, where data is represented as two primary types of subscribable data. This will probably make sense for anyone that's worked on RxJava, for example. So you have a mono, which represents a singular item at some point in time, and then you have a flux, which represents a variable size number of items at the point of time, which is accessed through an asynchronous subscription. So you have your repository, get by ID, then you can subscribe on that, and at some point the result will be in the subscribe function. Or you can just get by ID and pass this mono around if you handle it somewhere else. So if you look at a standard Spring Boot endpoint for WebFlux, the endpoint itself returns the mono. So you create the mono somewhere in your flow, and it gets returned to the endpoint, and then Spring gets the result and returns it asynchronously. So what you're actually doing is you set up the asynchronous flow, and then it's resolved in the controller at the end of your processing. Or if you have a list of items, you'd return a flux. So with coroutines, it gets simpler. You add the suspend keyword, and then you just return the element. And for a list of items, you can return a flow, which is the proposed solution, but you can also just return a list if you want. It does not have to be a flow. Yeah. So a lot of libs lack coroutine support, like a repository with the named template, for example. But the good thing is that Spring has, WebFlux has done a lot of work for creating extension functions on mono and flux. So you can get your mono, and then you can await singular null, for example, for a show endpoint. And then you can interface with the API that still uses only mono and flux, and you can get the result that works in your suspended flow. So that's endpoints for Webflux with coroutines. And these methods are then the ones that don't work with pre-authorize. And the second thing I want to mention with Webflux is what's called Web Client, which is their offering as a reactive client alternative to REST templates. It's a fluid API, which is normal for async implementations. So you want to do a get with a URI, then you retrieve it, and retrieve returns a mono, and then you call body to mono on that mono to get the body as a mono. That probably made sense, right? And then you can add block at the end to get it now. Of course, then it's synchronous and blocking, so then you kind of defeat the point. But working with quite a few Java APIs, we tend to see this because it's difficult to negotiate with other libraries. However, with coroutines, you say await exchange, i.e. you await the mono in the suspended coroutine, then await body, so you await the result of the body mono in the suspended coroutine. So you get the benefits of block while retaining both asynchronicity and non-blocking. So you get the best of both worlds in a way. Flow maps directly, so you don't need to do any magic for that. But of course, as programmers, we don't really want to choose. So why choose? We can do both. So we can say put with an URI and a body value, and then we say exchange for the mono, which has great observable functionality like retry backoff. So we can say we want to retry our actual exchange up to 5 times, and then we await first. So we await the actual body when it comes through, and then we can let on that to transform it to whatever we need. So if you take this, you get both the benefits of the mono and Flux observable interface and suspended coroutines. So if you would wrap that into a run blocking function and then have a recover catching below, then you would in effect have a circuit breaker pattern with using nothing but Webflux and coroutines. So that's an example of how Kotlin with its coroutines actually elevate things in Spring Boot and doesn't just convert it to Kotlin. So summarizing Kotlin plus Spring Boot, it generally works well out of the box. Unless you use suspended functions, that's a different matter. So if you have large Spring code base, or many Spring microservices, for example, as in our case, that are reliant on WebMVC, or specifically libraries that are reliant on WebMVC, like HateOS, for example, then you should think twice before refactoring or going for suspended coroutines, because you will encounter problems right now. But I know Spring is working on a lot of those issues, which is great for us. If you have any kind of Webflux variant, exclusively Webflux, you can get great gains in readability and concurrency through use of coroutines. So in effect, you get synchronous code. It looks synchronous, but it's not, and it's non-blocking. Yeah. So as I said, even with Webflux, there are still issues with Spring Security and many other WebMVC-based libraries. And that's our brief overview of Kotlin and Spring Boot. And now Jarle will talk about Kotlin Gradle.
Right, so we'll show sort of a very, very brief experience report about the pros and cons we have with Kotlin Gradle. We're using it, I think, for all of the Fraggles at this point.
Yeah, I think so.
So we're using it quite extensively. So the drawbacks is quite resource intensive. We're not sure why. You notice this really well when you're editing the file, that things take time. But as they said today, they're working on it, which is great. So hopefully this will improve. It can have unpredictable syntax when using plugins. This is an issue if the plugin has adapted, right, to the Kotlin Gradle syntax.
So many plugins have actually done the work they should to be more compatible for Kotlin Gradle, but we still have problems with some of them.
Yeah, I guess we have an example here. So this one, I think you can talk more about it. It generates Swagger code.
Yeah, so it's the Swagger Gradle plugin. I can't remember what its exact name is. But basically, you create the configuration underneath the Swagger sources configuration. So you need the magic string for what it's called. And then you need to apply, and then do a set input file. Because, of course, input file is immutable. And then you have this code block where you must create the closure with a type, and so on.
Yeah.
Well, the Gradle syntax is a lot more streamlined, as you can see. So for a lot of plugins, this is a general problem.
So there are advantages, of course. You don't need Groovy. So you can use Kotlin in the build script as well as your application, which is nice. You get code completion. I still remember the first time I had code completion in the build script. That was a great day. It works wonders with build source, so you can sort of extract the versions and stuff like that into build source. Incremental build and caching increases build speed. So we're using it. It works well. Hopefully the speed will improve, but actually we're all our services are converted into Kotlin Gradle at this point in Aurora. So that was just really short and sweet about Kotlin Gradle.
We've had a lot of pitfalls with Kotlin Gradle, so if you want to talk about it later, we can have a Kotlin Gradle support group outside. But a lot of these issues are quite involved, so we figured we shouldn't bring them up here.
A shoulder to cry on, right?
Yeah. Please talk to us later. We like Kotlin Gradle, though.
Yeah, we do like it. So we'll move on to the last main topic, which is the domain-specific languages. When we started using Kotlin for DSLs, we sort of distinguished between what we called external and what we called internal languages. An internal language is dependent on the host language. So in this case, it's going to be Kotlin. You write the DSL in Kotlin, and it runs in Kotlin. An external DSL is independent of the host language. A good example of this is CSS, which most of you probably know. So we did a comparison of these two because there was sort of a debate whether we should use an external or an internal DSL. For the external one, you would need to develop a parser that interprets the language. When it's an internal, of course, you get it for free because it's the language itself. We would need to create an editor for the external language. If you're using internal, you can just use the tools that the language already has, where IntelliJ perhaps is a good choice for Kotlin. External, you would have to create your own tools, and internal, you can use existing tools. So we chose to go the internal DSL route, of course, and we chose to use Kotlin. We're going to look at two use cases. It's a project for test data generation and a tax process, so for calculation and rules and stuff like that. Test data generation. The background for this is that the domain experts can easily produce rich test data. It's important to note here that the test data in the NTIA is quite involved. It can be thousands and thousands of combination of things. And if you change one parameter, it will change the control. So it needs to be easily accessible, and it needs to be often used by non-technical domain experts because they know the tax rules and they need to write the test data generation to provide good test data. So the number of test scenarios is very high, and it needs to be fast to create new rules, and it needs to be easy to test them. This project based their code on Kotlin Playground. Most of you probably know Kotlin Playground from examples on the web. It's basically you get an editor in your browser, you get code completion. It looks a lot like IntelliJ actually in your browser, which is really nice. So they created a fork of Kotlin Playground. They had to do some tweaks to make it run in our internal infrastructure. We have some custom stuff there where you need to package the applications a certain way. And we had to do some tweaks with the Docker image, but they made it work. It runs in our OpenShift environment. And of course, we had to tweak the front end. So the front end is basically written all in the NTIA, where we have our own design system with NTIA-specific colors, fonts, and stuff like that. So it is created for the browser. It should be easy to use. They shouldn't have to install anything. Just go to a web page and start typing in the test data they need. JavaScript manages the UI. And autocomplete is provided by the Kotlin server. Kotlin server is the repository that is basically Kotlin Playground. So we have an demo here of the tool where the domain experts start typing and it gets autocomplete. So he's here creating a person. This is in Norwegian, probably not everyone understand, but he's creating a person with a union fee for year 2018. You can create really involved structures here, and this is quite important. And this actually is a really nice way because you get the autocomplete support. It's really easy to get typing. And they know the rules, right? This is their language. It's written in Norwegian. That is the domain language in this case. So it's fast to use. They just type it in and they can push the button and it will execute on the server.
So an example of how it can be complicated. So here we have a monthly salary of 20,000 kroner. So let's say you change that to 20,500 kroner. That might trigger a different tax law somewhere. And only the domain expert really knows that that's going to happen. So it's very difficult for a developer to create realistic testing or realistic test data because they don't really know all the rules. So that's the main usage of this.
So benefits, the syntactic sugar that Kotlin provides. It really creates a great tool for natural languages. That, as you saw here, it was in Norwegian. You type it out as a sentence, and it looks really natural. The domain experts really liked that way of defining the rules. It's easy to integrate into existing legacy Java applications. Most of the time you have some legacy library, for instance, in Java. Just pull it in like you would in any Java application, and it works from Kotlin. Autocomplete and syntax highlighting out of the box with Playground. So that was the repository. They did some small tweaks too, but basically the pop-up here is from the Kotlin Playground code. Of course, there are some drawbacks. The Kotlin server project, it is large, and it can be hard to isolate what you really need. So we have a bunch of code there that's not really needed, but we haven't been able to remove it. And it is quite a big code base, actually. It does much more than we need, but it's kind of difficult to remove exactly the parts we're using. And we had multiple challenging adapting it for deployment into the internal infrastructure. So they had to create a custom Docker image. We had to do some tweaks to the server setup. But we did make it work, and it is running, but there was some work involved in it. It wasn't just taking an existing Docker image and putting it into OpenShift. The last point is a bit NTA specific, I think, because there are some custom stuff there that's not really normal. For instance, the way we package applications. Right, so moving on to the next DSL example.
Yeah, so that's tax process. We have, I'm not entirely sure when it started, but it's a pretty new project for the tax process in Norway. So right now, most users will encounter a large spreadsheet-ish site where you generally Google laws and try to make sense of what's there to actually enter numbers and hope you're doing the right thing. But the motto for the NTA is to make it easy to do the right thing. So that's why this process started. And what you get here is a more interactive, fluid experience where you get asked questions, and then we have validation logic that checks that that's a good idea, and if you do this, yeah. So it makes it easy to do the right thing. So it's rules-based, and these rules are both for helping the user make the right choices, and also for doing controls on tax returns to verify if the specific tax return has been done right, or if it has been done not right, and whether that is intentional or not. So basically, it starts with the project creating a set of rules from what they initially learned from the domain experts. And then they create these rules in the DSL we'll look at in a minute. And this is shown to the domain experts. And this gives the domain experts the necessary details to understand the DSL, because they are generally non-technical, but they are able to create and test new rules in this DSL. And this is very important, that this is an effective process, because there will be around 500 to 1,000 rules, and more specifically, they need to be maintained over time, because laws change all the time, and the developers do not have the domain knowledge and won't have the domain knowledge. Yeah. So this is the work-in-process UI for that. So basically, it looks even more a bit like an editor. And what this basically says is tax return, result 4, if group so-and-so, where at least 1 equals. All of this is anonymized, as you can see, because these are actual rules. And you can check for different groupings in tax returns. This specific rule is for verifying and helping the user during the tax process to say, okay, you've entered these and these data, then we can tell you that you should do this thing, for example. And the result you get from running this is something like this, where you have a lot of metadata for identification here. And then you have a part in the middle that says alvorlighetsgrad, which is Norwegian for severity, with a priority and a filter, so you can, in the front end, easily adapt this to show necessary information.
We can just say that this took a different approach. It's not using Playground.
Yeah.
This one. So this is a more of a custom solution that they created. This project was done before, actually in time. So that they set up their own editor and stuff like that. But they also have autocomplete.
Yeah, so basically this is posted to a backend, which runs this inline and produces a result. So the idea behind this is that you can have a domain expert write the control, they can test the control, and then they can deliver that control to a backend developer, which can implement it in production. So in that way, you get very precise and very fine-grained controls across tax returns that are produced by domain experts and not developers. So that is our presentation of the DSLs. Some key takeaways from our experience. Kotlin is great, I dare say fantastic, for developer satisfaction. The adoption resistance within the organization is minimal. And now Kotlin is actually an official language of the NTA. So developers can choose between Kotlin and Java for new or existing projects. Spoiler, they choose Kotlin. And it works well with existing libraries, but there are exceptions, such as threads, coroutines. For example, any thread-safe library in Java, you can just forget about being safe with coroutines. Migrating existing Java applications is a breeze. We have one large application in the Aurora platform for managing databases, which has been effectively converted to Kotlin feature by feature. So we produce all new features in Kotlin and do refactoring during that time. So you don't really have to set off time to say, okay, we're going to refactor this application now. You can do it while you actually do your work. Kotlin is also a great tool for DSLs and for build scripts. And our impression is that you can generally use it for the entire ecosystem. We were very interested in this Kotlin JS talk we just heard a couple hours ago, which might be another avenue for us for Kotlin. So that's about it. Do we have any questions before we wrap it up?
Otherwise, feel free to come down here. We'll stick around a bit.
We'll stick around and we'll be available. So please, if you find any of this interesting, come talk to us. We'd love to collaborate. We do as much open source as we're allowed to do. And we can talk about most of the things, at least abstract. So thank you, and remember to vote.